The second example, water enter the rotating Ron sprinkler through its base. So this is the base of the sprinkler at the steady rate of 100,000 milliliters per second. Okay, the axis area of each the two nozzle is 30. That is a two nozzle. Okay, 30 square millimeter, and the flow leaving each nozzle in the tangential direction. So this flow out is in the tangential direction. The radius of the axis of rotation to the center line of the each nozzle is 200. This is 200 millimeter. A. Determine the resisting torque required to hold sprinkler's head stationary. B. Determine the resisting torque associated with the sprinkler rotation with the constant speed of 500 revolutions per minute. And C. Determine the speed of sprinkler if no resisting torque is applied. Okay, so we draw the this is control volume. Okay. And given data, we given Q 100,000 milliliters per second, then C water area A2 at nozzle radius. So you want to find the torque if the angular velocity is 0. B torque if the angular velocity is 500 rpm, and angular velocity with if the torque is 0. Okay. You can draw the direction of the velocity. There are three velocity. U is the velocity of nozzle. So that is U is velocity of nozzle. U equal to R omega, and V is the velocity respect to the fixed point. So what is meaning of this? If you sit on somewhere here, you will see what you see is that the V2. Okay, it is V2, and the W is relative velocity respect to the nozzle. So it means if you sit on the nozzle, okay, we're going to see the flow out from nozzle with the velocity W2. Okay. Next we start to first problem is first question. So we use the equation of T formula equation. T sharp is equal to R2 V theta to M dot. Okay, in this case we use the fixed and non-uniform. And from T and for the V velocity, flow velocity out of the nozzle is the tangential. This tangential direction is mean that V theta 2 is equal to V2. Okay. So we can write that the T sharp is equal to 2V2 and M dot. Okay. Okay, and the next in case of this, we say that the V2 is equal to omega 2. Next we want to find what is the W2. W2 is equal to Q divided by area. convert to lit and convert to cubic meter. The area is convert to square meter and to nozzle. So that is the velocity flow from the nozzle, and the mass flow rate is rho Q is equal to density times flow rate. So we got 0.99 kilogram per second. Okay. The next we can find the T sharp is equal to for radius convert to cubic meter. For velocity we can use the 16.67 because in this case v theta 2 is equal to w2. Okay, and time the point. So the first answer we can find the T sharp is equal to negative 3.33 Newton. And for the part B, we allow that angular velocity is 500 rpm. Okay, so it's equal to convert to radian, 2 pi radian per round divided by, so we got 52.36 radian per second. And for V2 is equal to for V2 is equal to U2 subtract U2, that is the, you can see this one, V2 is equal to W2 subtract U2. And W2 is equal to 16.7 from the previous calculation, and V is equal to 16.6 for U2 is equal to omega. Substitute the radius, and omega is 52.36. So we got the B2 is 6.2. And next we can substitute the equation of T sharp. Go to 2V2 m dot is equal to radius times the velocity in time density. So we got 1.24 Newton meter answer for. So that this is T sharp if the angular velocity is 500 rpm. Okay. And next, if T sharp is 0, this means this term is equal to, if we substitute U2 is equal to R2 omega, and prove that omega is equal to W2 divided by R2. P2 is 16.67 divided by radius. We got 83 point. Okay, and we can convert to RPM. Okay, so we can see that T sharp from choice A is greater than from from part B, and if the T sharp is equal to 0, it means is the angular velocity is limited to some number.